All right, hello everybody. Today we are going to continue our discussion over sig figs. Last week we talked about adding and subtracting sig figs. Today we're going to discuss multiplying and dividing. We're also going to get into scientific notation. So hopefully the scientific notation should hopefully be review, but sig figs will be new, but I think they're a little bit easier than adding and subtracting. So let's get into it. Okay, when you're multiplying and dividing sig figs, you need to worry about, so your answer can have no more sig figs than the measurement with the fewest number of sig figs. So basically, just like what we did on Friday last week, you need to worry about solving first, then look back at your original numbers to figure out which one has the least amount of sig figs. Now, the helpful thing about adding or multiplying and dividing, you worry about all of the sig figs, not just the ones behind the decimal like you did on Friday. So this is kind of like what we did in the very first part of your homework on Friday. You just tell me how many sig figs there are. So just like what we did on Friday, the first thing to do when you get into a problem is you're just going to solve it. Solve, then go into your sig figs. So you're going to take into your calculator 3.05 grams divided by 8.47 milliliters. And when you do that, you should get an answer of 0.36009445. Okay, so I like to write out the whole number so that I don't have to worry about running out of space or not having enough numbers for my sig figs, and then I can go in and fix it from there. Okay, so now I need to look back at my numbers and figure out how many sig figs are in my original numbers. So I have 3.05. I look, 3 I know is a sig fig, that 0 is a sig fig because it's sandwiched between two numbers, and 5 is a sig fig, so this one has 3. Leave myself a little note. 8.47, 8's a sig fig, 4's a sig fig, 7's a sig fig, so there's 3. Well, these are both the same number, so I'm going to go to 3 sig figs. Makes my life a little bit easier. Then I get back to my number. Well, I have to look and figure out, is this 0 in the beginning, is that a sig fig? Well, if you remember our rules from Friday, leading zeros are not significant, so this one is not a sig fig. So 3 is a sig fig though, 6 is a sig fig. This 0 counts because it's sandwiched between two numbers, so there's 3 sig figs. I'm going to look behind, it's another 0. So with our rounding rule, I'm going to stay the same. So my answer should be 0.360. And then I look at my units. I have grams and milliliters, grams per milliliter. And that is my final answer. All right, let's move on to a couple more examples. So when we're multiplying, again, exact same thing as what we just did. So first we're going to solve. So I'm going to take 2.4 grams per milliliter times 15.83 milliliters. When I do that, I should get an answer of 37.992. Okay, now I have to go back into my numbers to figure out how many sig figs do I need to go to, because I always want to go to the least amount. Well, I know 2 is a sig fig, so we're good there. Put that in red. 2 is a sig fig. 4 is a sig fig. That means I have 2 sig figs and 2.4. 1's a sig fig, 5's a sig fig, 8's a sig fig, 3's a sig fig, so I have 4. Again, remember, in chemistry, we want to do the least amount of work possible, so I'm going to go to 2 sig figs. And again, I'm worrying about the entire number this time. So I'm going to start at the beginning with my 3. Go 1, 2, because they're both sig figs. I look behind, it's a 9, so I'm going to round up to 38. I look at my units, I have grams and milliliters. Well, I have 2 milliliters, so they cancel each other out. So I'm just left with grams. So I have 38 grams. Okay, then I check, that's my final answer. I went to 2 sig figs, my answer's in 2 sig figs, we're good. Okay, next one, I have 1.34, that's a micrometer, so that's a very, 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 very small number. So we have 1.34 times 0.7488 micrometers. Okay, so now I have to figure out, when I multiply these two numbers together, you should get an answer of 1.74 0, 0, 3, 3, 9, 2. Okay, now I have to figure out how many sig figs do I have in each number. So I know 1's a sig fig, 3's a sig fig, 4's a sig fig. So this one has 3 sig figs. I go to my 0.7488. I know that 0 in the front is not significant, so it does not count. 7 does count, 4 does, 8 does, that 8 does, so I have 4. I always want to go to the least amount, so I'm going to go to 3, and so I'm going to go to 3 sig figs. Well, since I have a decimal in the front, I go to the very front. The first number I hit is a 1, so that is a sig fig. Makes everything behind it significant, so I don't have to worry about the zeros. So 1, 2, 3. I look behind, it's a 3. So that means my answer is going to be 1.00 micrometers. All right, let's do the very last example here. So I have 10.8 centimeters times 102 centimeters. I'm just going to solve it out like I normally do. And I'm going to get an answer of 1,101.6. Now I need to figure out how many sig figs I need to go to. So I look, 1 is a sig fig. 0, that 0 is a sig fig because it's smashed between two numbers. And 8 is a sig fig, so I have 3. And I look here, 102, 1 is a sig fig. 0 is because it's stuck between two numbers. And 2 is a sig fig, so that means I have 3 sig figs. So since they're both 3, I'm going to go to 3 sig figs. So I go 1, 2, 3. I look behind, it's a 1, so I'm going to stay the same. Now, the problem is, my answer would be written as 110. But is 110 the same as 1,101? No. So this is where we have to add in that placeholding 0 that we talked about on Friday. I cannot add a decimal though, because right now I have 3 sig figs. If I added a decimal here, that makes this 0 significant. So I have to leave off the decimal so that I have the correct number of sig figs. So that means my answer will be 100 micrometers. Or sorry, centimeters. So if you ever get to a point where you need your numbers don't match up or they're not close enough to each other, so instead of having 110 as your answer, you add that placeholding 0 to be able to get it as close as possible to the correct answer. Okay, so again, remember, when you're multiplying, dividing sig figs, worry about all of the sig figs. Adding and subtracting is just behind the decimal. All right, let's do a couple quick checks. So what is the sum of 7.3 meters and 42.09 meters? Okay, well, first I have to figure out what type of math am I doing. The word sum means to add, so that means I'm going to add these two numbers together. 7.3 meters plus 42.09 meters. Well, since I'm adding, I only worry about what's behind the decimal. So when I solve that, I should get an answer of 49.39. Well, I have to look. I look behind the decimal of 7.3. 3 is a sig fig, so there's 1 sig fig here. 42.09, that 0 is significant, and so is the 9, so there's 2. So I'm going to go to 1 sig fig behind the decimal. I go to my 3. I look behind, it's a 9. Should be 49.4 meters. So 39.4, so that's saying we should have letter C as our answer. See if we are correct. There it is. We are. All right, let's do another one. This time we're dividing. So we're going to solve for 24.355 divided by 6.213. So we're dividing this time, so we need to worry about all of the sig figs. So first I'm just going to solve. When I solve 24.355 divided by 6.213 equals, should be 3.920000644. Okay, so now I need to put this into the correct number of sig figs. And again, I'm worrying about all of the sig figs. So I'm going to count how many I have. So I start at the beginning. 2 is a sig fig. 4 is. 3 is. 5 is. 5 is. So there is 5 sig figs. And then I go to my next numbers. 6 is, 2 is, 1 is, and 3. So that would be 4 sig figs. I'm going to go to the least amount, which would be 4. So I'm going to start from the very beginning. 3 is a sig fig. This 9 is, 2 is, 0 is a sig fig because it's stuck between two numbers. I'm going to look behind. It's a 0. That means my final answer should be 3.920. So it's saying letter B should be my final answer. And we are correct. 3.920. So, major things to take away. Adding and subtracting. You are worried about what's behind the decimal. Multiplying and dividing, you worry about all of the sig figs. Always solve, then sig figs. Okay, now we're getting into scientific notation. So scientific notation, numbers are written in the form of m times x to the nth, where m is a number greater than or equal to 1, but less than 10, and n is a whole number. So m is referred to as your base unit, while n is your exponent. When writing numbers in scientific notation, only the sig figs are used. So that's why, well, when we use scientific notation, especially for those really big numbers or really small numbers, it's just easier to write it as a scientific notation of whatever it is times whatever power, instead of having to write out a million numbers. It just saves us a lot of time and headache. Also, same thing if we have to write a really, really, really small number and we have a super small decimal with lots of zeros in it, just saves us a ton of time. We also only have to worry about the sig figs when we're doing scientific notation. So if there's a bunch of zeros in the front, those aren't significant, so we don't have to put those into our scientific notation. So to determine the m, by moving the decimal point to the original number to the left or right so that only one non-zero digit remains to the left of the decimal point. So we really only want one digit in front of the decimal. So only one. Determine the n by counting the number of places the decimal was moved. So if the decimal was moved to the left, the n value will be positive. If the decimal point was moved to the right, then the n value will be negative. So if we do this example up here, so we have 0.00012 millimeters. So if we wanted to make that into scientific notation, what I like to do is I like to take my decimal point and I'm going to move it until I have one number in front of it. So I'm going to keep jumping until I have one number in front of it. So right there, I have one number. So my answer would be 1.2 because these zeros in the front here are not significant. So we do not need to count them in our scientific notation. So it would be 1.2, because these are our only two sig figs, times 10. And I moved it 1, 2, 3, 4 places to the right. So it's going to be a negative 4 millimeters. So it'll be 1.2 times 10 to the negative 4th millimeters. Okay, so now when I do my 93,000 kilograms, my decimal is in the back here. And I'm going to move it till there's only one number in the front. So nope, not yet. not yet, and there. Only one decimal to the left. So now I'm going to write it out. And again, initially there was no decimal there. But since I came in, there's only two numbers in the front. So it'd be 9.3 times 10 to the 1, 2, 3, 4, positive 4 kilograms, because I moved it to the left. So let's do a couple more examples. So let's place these into scientific notation. So I have 3,340 centimeters with a decimal there. So let's tell them I'm going to go to the front. Everything behind it is significant, so we will write that 0 out. So I'm going to start with my decimal, put my pencil there, and I'm going to carry it over until I only have one number in front. So not yet, not yet. There we go. So that's my new decimal spot. So I have 3.340 times 10 to the 1, 2, 3. And since I'm moving to the left 3 spaces, it's going to be a positive 3. Okay, let's do B. So I have 0.006000. So I'm going to move it until I have one number in the front. So here's my decimal point. Move my pencil until there's one number in front. All right, so we're good there. So it's going to be 6 point. Well, these 3 zeros in the back here are significant, so I'm going to write those in. 1, 2, 3 times 10 to the 1, 2, 3. And since I moved it to the right, it's going to be a negative 3. Make sure you can actually read that. Okay. One more. So 45,000. Ooh, there's a couple extra numbers in here. Should be a decimal point there. I suggest leave off the commas just because a lot of times those can be confused as decimal points. So if you just leave it off, I will never count it wrong if you don't have commas. And a lot of times we put them in the wrong place, even like what I did here. So it helps just leave them off. You don't need them. Okay, so we're going to say our decimal point is back here. We're going to move it till we have one number in the front. So I'm going to have not there, not yet, nope, nope, and there we go. So we should have, and since all of those are significant, we're going to write all those numbers out. 4.50324 times 10 to the 1, 2, 3, 4, 5. Again, since we moved it to the left, it'll be positive. All right, now there are times we have to go backwards, and we go from scientific notation to the standard form. So move the decimal to the number of places indicated by the n value. If the n is positive, move the decimal to the right to form a larger number. And if the n is negative, you're going to move the decimal to the left to form a smaller number. So if it's negative, you move it to the left to make a smaller number. If it is positive, you remove the decimal to the right to form a larger number. Okay, so for example, we have 2.3 times 10 to the 5th. So that 5 is positive. So that means I'm going to move my decimal point 5 places to the right. So that means I'm going to put my point here. I'm going to go until I have 5 places. 1, 2, 3, 4, 5. And every empty space gets a 0. So that means my answer would be 2, 3, 1, 2, 3, 4 zeros. Okay, now if we go the other way, we have 2.3 times 10 to the negative 5th. We're going to move it to the left to make a smaller number. 1, 2, 3, 4, 5. Put our decimal point there. Every empty space gets a 0. So that means our answer would be 0.1234 zeros, 2, 3. we're just basically going backwards. So I like to think if it's negative, you're going to make it smaller. If it's positive, you're going to make it bigger. That's just an easy way to check. Positive exponent, bigger number. Negative exponent, smaller number. Smaller numbers are going to have the decimal point with a bunch of zeros in the front. All right, let's write these as standard form. So we have 4.70 times 10 to the 7th. Well, 7 is positive, so it's telling me I'm going to make a bigger number, which means I need to move it to the right. So I'm going to take my decimal. 1, 2, 3, 4, 5, 6, 7. There's my 2 decimal point. Everybody gets 0 where the empty spots are. So we have 4, 7, 1, 2, 3, 4, 5, 6 zeros. So that's much better to write as scientific notation than writing it out longhand. All right, 3.2 times 10 to the negative 4th. Well, I have a negative number as my exponent. That means I'm going to have a smaller number. So I'm going to move it to the left. So I'm going to go 1, 2, 3, 4. Place my decimal point. Everybody else gets a 0. So it would be 0.00032. All right, now we have 9.7 times 10 to the negative 1st. Again, so I have a negative exponent, which means I'm going to have a negative number or a smaller number. So I'm going to take my decimal, move it 1 place to the left. So I have 0.97. All right, I have 5.1 times 10 to the 0. Well, I have a 0 here. So it's telling me I don't move anywhere. That means my final answer is 5.1. So it doesn't change if there's a 0 as an exponent. It stays whatever that number here is. You're not going to see that very often. You're going to be more dealing like A, B, and C. All right. Oops. All right, one more check and then we'll be done. So which of the following is the correct scientific notation for the value of 0.000589? Okay, so we need to put this into scientific notation. So I see it's a small number, so I know I'm going to have to move my decimal point to the right, and I should have a negative exponent. So let's count how many I need to move. 1, 2, 3, 4 places. And again, all those zeros in the front are not significant, so they will not be written out. So it would be 5.89 times 10. And we said 1, 2, 3, 4. But since we moved to the right, it would be a negative 4. So it's saying that letter A should be our answer. And we are correct. So remember, scientific notation, depending on which way you're moving, is going to dictate whether you have a negative or positive exponent. And again, depending on if you're starting from scientific notation going to standard form, again, you have to look at your exponent to decide which way you're going to be moving. If it's a negative number, it should be a small, or if you have a negative exponent, it's a smaller number. If it's a positive exponent, it's going to be a bigger number. So you can always check your answers as you go. All right, your homework is the back side of your worksheet that we did on Friday. That was due today. So make sure, show your work, show how you're moving it, just like what I did here today. There's also a part about scientific notation. So I should see that. So I should see work written out just like this. So I can keep track of where you are and how you're moving. So if you have any questions, shoot me an email. I will be back tomorrow, and we can go over any questions you have. Have a great rest of your day. See you tomorrow.